Welcome to This Explainer. For all the IT and security professionals tuning in, we are unpacking what is, without a doubt, one of the most massive, paradigm-shifting events in the history of information processing. I'm talking about the dawn of quantum computing and the absolute critical need for quantum defense. We are standing at a major crossroads right now. The underlying cryptographic foundations that protect our global communications, financial transactions, and critical infrastructure, well, they're about to be severely tested. So my goal today is to break down exactly what this quantum leap means for your networks, and honestly, more importantly, how you can start future-proofing your systems today.
Okay, let's dive into this. Our roadmap is going to logically guide us right from the abstract theoretical threats all the way to highly practical, everyday infrastructure solutions. We'll be hitting 5 key areas. 1. The quantum era. 2. Today's risk. 3. Standards and hybrid strategy. 4. Post-quantum VPNs. And finally, 5. Continuous readiness. Let's get right to it.
Section 1. The quantum era. And I really want to emphasize here, this isn't just your standard tech upgrade. It's a fundamental shift in how technology actually works.
To grasp this, we have to contrast classical bits with quantum qubits. Classical computing, which runs pretty much everything today, relies on linear bits. It's an either-or scenario, a 0 or a 1. Think of a bit like a coin sitting flat on a table. It's either heads or it's tails. But a qubit, that's like the coin spinning in midair. Because qubits exist in multiple states simultaneously, quantum computers can process just massive volumes of data and identify incredibly complex mathematical patterns in seconds. Stuff that would literally take classical systems millennia to figure out.
Now, what's really interesting about this time frame is the ticking clock. It's honestly a bit terrifying. We're looking at a window of just 5 to 15 years before quantum computers mature enough to completely break the cryptographic systems we rely on today. Think about that for a second. Within a decade or so, the security layers shielding our global finance systems, corporate VPNs, and critical public infrastructure will become completely obsolete if we don't adapt.
So what does this actually look like under the hood? It all boils down to 2 theoretical mathematical formulas that become very, very practical on a quantum computer. First, you've got Shor's algorithm. This is the big one. It can efficiently factor large numbers, which means it systematically dismantles the asymmetric encryption used in PKI, completely breaking RSA and ECC. Then you have Grover's algorithm. Now, while Grover's doesn't instantly shatter symmetric encryption like AES, it severely weakens it. It dramatically reduces its effective resistance, meaning we're going to need much, much larger keys just to maintain the security levels we have right now.
Section 2. Today's risk. And I want to shift gears here, because as network administrators, you have to act now. The danger is literally already at our doorstep.
You might be thinking, hey, we've got a decade to figure this out, right? Well, that brings us to a chilling reality, known in the industry as harvest now, decrypt later. Think of it like a giant Trojan horse. Right now, as we speak, adversaries are passively intercepting and hoarding your highly sensitive encrypted data. They're essentially stealing your locked data safes, fully aware they can't crack them open today. But they're just patiently waiting in the shadows for that quantum master key to be forged. By the time quantum tech is operational, your sensitive data from today will be wide open to them.
And you know, it actually gets even more insidious. We are already seeing what's called malicious PQC. Next-generation firewalls are currently detecting adversaries who are exploiting unauthorized open-source post-quantum cryptography tools today. Why are they doing this? To hide malicious activity deep inside networks. They're using these advanced techniques to mask anomalous SSH sessions and obfuscate their cryptographic traffic, basically slipping right past legacy security controls. Section 3. Standards and hybrid strategy. Okay, let's transition into some solutions, because the industry actually has a really robust, pragmatic response to this looming crisis.
We've established the threat, but it's definitely not all doom and gloom. NIST, the National Institute of Standards and Technology, has really stepped up. They've introduced some new cryptographic standards, essentially the new heroes of our network defense. We've got FIPS 203, which utilizes Kyber for highly efficient key exchanges. Then there's FIPS 204, using dilithium for robust digital signatures and identity validation. And finally, FIPS 205, which uses Sphinx Plus as a hash-based fallback security algorithm. These standards are literally the bedrock of the post-quantum world.
But look, we obviously can't just flip a switch and abandon classical cryptography overnight. That's just not realistic. That's where modern TLS hybrid cryptography bridges the gap. Here's how this highly complex handshake actually plays out step by step. First up, the client and server generate both classical and post-quantum keys at the exact same time. Second, they execute completely independent exchanges for both key types. And third, they combine those two distinct secrets together to form the final, ultimate session key.
And this brilliantly illustrates the elegance of the hybrid approach. By combining a trusted classical algorithm like X25519 with a cutting-edge post-quantum algorithm like Kyber 512, you truly get the best of both worlds. You're maintaining your immediate security posture against traditional threats while simultaneously future-proofing your data against quantum interception. It's a single hybrid key capable of resisting both classical and quantum attacks.
Section 4, Post-Quantum VPNs in Practice. Now let's pivot directly to the day-to-day responsibilities of a network engineer and see how we actively secure site-to-site VPNs.
When we compare traditional IKv2 setups to modern post-quantum VPNs, the vulnerabilities of the old ways are super glaring. Traditional IKv2 relies heavily on Diffie-Hellman key exchanges, and as we know, those are highly vulnerable to quantum attacks. Plus, the key and the payload travel on the exact same channel, which introduces native man-in-the-middle risks. But contrast that with the advanced hybrid models found in RFC 9242 and 9370. These use post-quantum pre-shared keys and multiple key encapsulation mechanism rounds. It is an absolute massive leap in defense.
Now, if you're actually out there configuring these tunnels, you need to verify they're working, right? Consider this your practical checklist. You can jump into your CLI right now and run commands like show VPN IPCSA to check the tunnel status, or test VPN IKE-SA gateway to initiate phase 1. And if you monitor your IKE manager logs in real time using tailfollow, you'll confirm that your devices are negotiating both classical and PQC encryption simultaneously. It's all about validating that hybrid defense is actively doing its job.
There's also another completely fascinating approach alongside hybrid encryption called quantum key distribution, or QKD. This completely changes how keys are shared. Step 1, keys are generated using actual quantum physical principles. Step 2, they are transmitted via a completely separate dedicated quantum channel. And Step 3, the devices sync these keys out of band. Because the actual key itself isn't sent over the standard IKv2 channel, only its identifier is, the risk of that secret being intercepted over the network is completely neutralized.
Section 5, Continuous Readiness. Let's move into actionable preparation tools you can use right now.
As we move from VPN theory into actual deployment, you have to ask yourself a very targeted, uncompromising question. Where exactly is cryptography being used in my network? Think about it. You simply can't protect what you can't see. Conducting a direct, active assessment of your own infrastructure is literally the most vital step you can take today.
To help answer that question, tools like the Strata Cloud Manager offer what's called a quantum readiness view. And honestly, this is the ultimate empowering tool for security teams. It gives you centralized visibility into every single cryptographic algorithm running on your network. It builds a usage inventory, provides active migration recommendations, and tracks your security posture evolution. If you have Gen 4 next-gen firewalls and PAN-OS 11.1 or higher, you already have the centralized logging required to execute a seamless, confident migration strategy.
I want to wrap up this explainer by leaving you with this really provocative thought. The future of security is ensuring data remains protected against technologies that don't even fully exist yet. The quantum threat is absolutely real. Those Harvest Now attacks, they're happening as we speak. But as we've just seen, the standards and the tools to defend ourselves are already here. It's entirely up to you to evolve your cybersecurity posture starting today. So challenge your teams, audit your networks, and begin your transition into the post-quantum world. Thanks for joining me, and stay secure out there.